from here. So I have 160 times 4 plus t squared minus 4t squared divided by 4 plus t squared cubed. You know, you got to check this stuff. What happened to the t? T times t is t squared. Okay, so I'm going to check mine, make sure, see if I can find it here. By golly, it's right. According to my work there. I'm not worried about that denominator. I should be sure it's right, but I'm not worried about it because when I set it equal to 0, what's the only portion of the fraction that makes any difference? The numerator. So I'm going to say 0 equals 160 times this. And that gives me that 4 minus 3t squared is the only 0 I could have. So t would be, let's see, square root of negative 4 divided by negative 3, or 2 divided by the square root of 3. I should have a plus or minus in there, but do I really need it? You take the square root, you got to be careful. Why would I not need to have a minus in here? What's t stand for? Yeah, the negative, t stands for hours, so I'd have negative hours. Okay? So would you walk in someplace and say, well, I'll tell you what, your greatest rate of assembling is going to come 2 divided by the square root of 3 hours after the first. No, you wouldn't do that. Okay? You'd probably take care of an approximation. And I've got approximately 1.15 hours after the student starts working, you're going to get the greatest rate. Now, are they going to be assembling the most at that time? Well, if they're working the fastest, now the greatest rate means that the rate at which they get it done is increasing over time. And so that is something that we'd have at the greatest rate. They're not assembling that many per hour. And the number that increases per hour isn't going up by 1.15, but the rate at which they're assembling is going up. The rate at which is going up that much. Okay. These are interesting problems. And we have to, first of all, understand what it is we're trying to find. And this one, let's go back, because this was an interesting problem. It says, not that. Let's go back to where we were. The problem says something else. There we go. There we go. At what time is a student's assembling components at the greatest rate? Okay. So yeah, at 8:15. They're assembling them the fastest that they will ever assemble in the whole. Now, how do we know it's a maximum? We didn't really test that, did we? That could be just an extrema. That could be maybe the slowest rate. We have to go in there and kind of check around a little bit, but we'll leave that problem for now. Okay, the next, and again, what we're heading toward is that section of optimization, the one where all we do is look at things like this. Before we get going there, and I got some quizzes for you, we have this thing called the point of diminishing returns. Have you heard of that in the business? What do you know about it, Cole? Make your business profs proud. What do you know about it?
The point at which
you're not going to read off the screen, are you? Goes down. Okay, output per worker goes down. He applied something a little different. Is that consistent with what we have on the screen about dollar amounts? In what class did you learn about that? Econ 1. Okay. So Econ 1 maybe is a better connection with this class than Econ 2, as I always thought. Okay? The point at which each dollar begins to return less. Now, what Cole said it would be the point at which each worker produces less, begins to produce less. Is that what you're saying?
Well, it's like if you add more workers onto one task, like the input of the workers, it's kind of like a competition of space, so they do less work per worker.
So your input would be the number of workers, and your output would be what? Output? I mean, product output? Okay, so as you put more workers on, does that mean you're going to get less output? So in this case, we're not going to get less dollars, and if I apply that to what Cole said, we wouldn't get less product from those workers. We just wouldn't get the increase on the amount of product as we were seeing back here. Now, let's look at that. If I draw a tangent here, and I continue to draw tangents along here, the tangents are getting steeper, which means that the rate is greater. And then all of a sudden at this point, for one thing, what happens to the tangent lines? Ryan? They decrease, but what else? I can't hear you. That's true, but what else? That's true, but what else? There's something else that happens. If I'm going to draw a tangent line along this curve, let's see if I can get that. Where's my magic marker thing? If I'm going to draw a tangent line, there we go. And I'm going to pick up that line, and I place it here, and then I place it up here. What happened to that tangent line? Because there's a point where I'd have the same slope, but what happens to this tangent line from going here to here? It's on opposite sides of the graph. Yeah. Did you notice that? Here's below the curve. Where do you suppose it switches? And what's our name for inflection point now? Point of diminishing returns. Because if I take this and I begin to work it around this curve, I am getting slopes that are now beginning to level off. And so I'm still increasing in my output, my product output, or my dollars or whatever, but I'm not getting as much benefit from each additional worker or from each investment dollar that I put in. So the point of diminishing returns. Okay, we'll take care of that. I've got your quizzes, so sorry to keep you 2 or 3 minutes late, but you will, some of you want to see these. What I did was I took the extra credit and I applied it to this course, so that gave you an A+ on this. In other A+, and so I applied it to points. Listen carefully, if anyone wants to know this. I applied it to points above. I applied it to a column by a spreadsheet that says extra credit. So I'm going to add up all the points I have for quizzes. But I'll divide by one less column, the extra credit column. Down there, please. Alice? Why not? I got all of mine. Haley? Angie? 7. Ryan? Get it? It's like I either had 8 or I had 2 counts. Philip. Down to Philip. Alyssa. Down to Alyssa. Aaron. Charlie. Remember that there's a special buzzer that's going to go off. You put that in the multipliers.